So the set of irrational numbers are numbers that cannot be changed into fractions. So it's the total opposite of rational numbers. Irrational numbers can consist of pi. Pi is a perfect example of an irrational number because it has a weird value, 3.1415, I don't know what's after that. So pi is an irrational number, it cannot be changed to a fraction. Another example of an irrational number would be the square root of 2. Square root of 2 has a weird value, cannot change into a fraction. Same thing with the square root of 3. And then we skip the square root of 4 because the square root of 4 gives you 2. 2 is a rational number. After that would be the square root of 5, and then so many other numbers after that. So irrational numbers are numbers that cannot be changed into fractions. Then the last one would be the real numbers. The set of the real numbers. And the real numbers is the entire set of all these elements here. So it can consist of natural numbers, whole numbers, decimal values, 1.5, it doesn't matter, fractions, negative 2/3, even irrational numbers like pi, and square roots. If you can think it, it's a real number. Okay, so now we're going to go ahead and talk about going back into the previous video's notes about sets and subsets. If you look over here, the set of the natural numbers and the set of the whole numbers, they look exactly the same except that the whole numbers has the number 0. So you can say that the set of the natural numbers is a subset of the whole numbers because all the elements in the set of the natural numbers can be found in the set of the whole numbers. Hello, ma'am. Okay, so what we're going to do next is we're going to go ahead and draw a picture diagram, a Venn diagram, representing all these number sets. A visual representation of this. So here we have the set of the natural numbers. That's the smallest. After that we have the whole numbers. All the elements in the natural numbers can be found in the set of the whole numbers. After the whole numbers we have the integers. And then the integers is a subset of the rational numbers. But now when we get to the irrational numbers, we had mentioned earlier that rational numbers and irrational numbers are complete opposite of each other. Rational numbers make sense. You can change into fractions. Irrational numbers don't. They can't be changed into fractions. So the rational numbers and the irrational numbers have nothing in common. They don't have any elements that they share. Therefore, the irrational numbers have to be on the side. None of those elements belong over here. None of these elements belong over here. And then finally, the universal set is the real numbers. Each of these sets is a bigger set than the previous set. And this is how you draw a visual representation of these sets.